All right, guys, this is an introduction to variable expressions, and I'm just gonna jump right into it. But first, let me go over some properties that are used for variable expressions. So here's a property. One of the first properties called the associative property, which is basically saying if you have three factors, A, B times C, no matter how you group them, it's gonna be the same solution. So the quantity AB times C is the same as A times the quantity BC, and that's called the associative property. And it's basically the same for addition. So for example, if they had A plus B, the quantity A plus B plus C, it'll be the same as A plus the quantity B plus C. And I probably think they have that later down. And then there's the most famous one called the commutative property, which is basically saying that you can reverse multiplication. Because A times B is the same as B times A. AB is the same as BA. And there's also a commutative property of addition, which says A plus B is the same as B plus A. And then you have the multiplication property of 1, which basically says any factor times 1 is that factor, right? Any factor times 1 is that factor. And as you can see, they have it commutatively done here too, and you get the same results. And then there's the inverse property of multiplication, which is basically saying if you multiply a factor times its inverse, you'll get 1. Right? So that's what they're saying, that if you multiply a factor times its inverse, which is also called the reciprocal. Oh, I finally know how to spell it. Right? Or multiplicative inverse of A. It's a beautiful word. Okay? So we're going to just jump right into these properties. I'm not sure you're going to see these on your exam, but a long time ago, you would have like a multiple choice that say AB equals AB is which property? A, the associative B. The commutative, or C, usually is the distributive property, but I didn't see them mention it here. But like I said, I'm just jumping in and I'm going to follow your text. So here we go. Let's try to simplify this expression that is expressed as a product. So it's this product expressed as a fraction, I should say. So here it's 7/5 times 5x over 7. So basically, the only difference you're seeing here is that you're seeing a variable as a factor. But not so long ago, we were doing multiplication of fractions. And clearly, you see an expression like this. You see that it has a common factor of 7 in the numerator and denominator, which leaves a factor of 1. A common factor of 5, and this solution here would be 1. So the only difference here is that they added on another factor to it. So basically, if I cancel out these factors, I'm left with the factor x. So 1 times x is just x. And we don't say 1x because that's redundant because we have 1x. All right, so basically that's what that looks like. Let's try a few examples in your book. Here we have two factors. We have a factor of positive 2 times positive 5x. So that's positive 2 times positive 5x, which is basically you multiply the factors, the constant factors that you can, right? So this is like saying 5 times 2 times x, which is 5 times 2 is 10, and we're just left with 10x. All right. The rules of size is still applicable. Here we have a negative factor times a positive factor. And the rules of sign basically says that when we have factors with unlike signs, it yields a negative solution. Also, we have, when we have factors with like signs, it yields a positive solution. Okay, so basically, this is what your multiplication, simplifying factors looks like, especially in fraction form. Let's do another one. Here we go. Here we have negative 8y times negative 1 over 8. It's inverse. That's why they were showing you those properties so you can apply them. So it's 8, negative 8 times its inverse. And what we learn is that whenever you have a factor times its inverse, it's usually a 1, but then there's also another factor of y there. So a negative times a negative is a positive, and 1 times y is good old y, right? A lot of times students get confused when they see a fraction and a whole term. So let me just do an example of that. So we have 1 over 5 times the factor 15x. And just in case things confuses you a little, just rewrite that whole number as a fraction. Here we go. And as I taught you, if you can't see clearly that 5 and 15 has a common factor of 5, then just break down your composite number 15 into prime factors, right? There you go, over 1. So here you see they have a common factor of 5. You can cancel out the 5 and you're just left with good old. Some of you are tempted to put 3x over 1, but that's also as redundant as saying 3x. And the rules of signs still apply. Now, yeah, we have some room. Like I said, I like to keep my videos under 15 minutes. Let's take it a little further. There's another property that they introduced you to, and I did mention it earlier. It's called the distributive property. So here the distributive property is saying anytime you have a factor times a group of terms, right? Whenever you have a factor times a group of terms, and remember this parentheses converts terms into factors, and that's why a multiplication operation is able to be used here, because we have a factor times another factor, which is a group of terms, and we call this the distributive property. So the distributive property stays a little true to the word distribution. So what happens is that we distribute the factor to every term inside the parentheses. But when we say distribute, it's really a multiplication operation that occurs. And we're able to multiply because both of these are factors. This is one factor and this is a group of two factors because the parentheses made it a factor. So this is saying A times A is AB. A times B is AB plus A times C is AC. That's the distributive property. So here we go. We have a couple examples of what the distributive property looks like. And here they have an expression where they just have a negative outside there. So they're treating the negative as a factor, right? That's what they're treating the negative here, right? So there's a couple ways you can look at this. You can rewrite this expression as saying we have one factor of this group. So, we can write that redundant one, right? 4x squared minus 2x minus 3, right? And then we can apply the distributive property, the distribution of that negative one to all the terms inside. So when we have a negative times a positive, we'll get a negative. We have a negative times a negative, we'll get a positive. And we have a negative times a negative, we'll get another positive, right? So whenever the sign of factors are unlike, it yields a negative. And when the sign of factors are alike, it yields a positive. Also, I spoke about earlier in our lessons that negative actually also means to take the opposite. Take the opposite. So the opposite of positive 4 is negative 4x squared, the positive, right, of positive 4x squared. The opposite of negative 2x is positive 2x. And the opposite, so we could treat this as the opposite of negative 3 is positive 3. So boom. So you see there's at least two ways you can look at it. Now let's look at a problem where there's actually constant factors other than one that comes before the parentheses. So here we go. Here we have a negative 4 times A plus 12. So distributive property right here, that's negative 4 times positive A is negative 4A. And negative 4 times positive 12 is negative 48. So that's the solution to our problem. Here we have another example. And then there are examples with positives. Let's try one with a positive. So we have a positive 4 times the quantity 5, negative 5x squared minus 2. Same rules of sign apply. Positive times negative is negative, so it's negative 20x squared. Positive times negative is negative 8. All right. So will there be positive expressions all the way? Yeah, you can have some positives right here. There's an example of positives. Um, some more examples where the factor outside is positive. So like I said, you can have 100 terms inside of this parentheses. Once it's put inside of a parentheses and there's a factor before it, you can apply distribution, the distributive property. Now, what they do in the next video, we're going to do other examples where the problems get a little more challenges, a little more lengthy, where you got to apply several different properties. You got to apply mostly what kicks in here is order of operation, where you got to do what's in parentheses first, and then you got to multiply, which is distributive property, and then you got to combine like terms. We're going to do more of that in the next video.